Imagine looking up at the night sky, seeing the stars shining softly, and forgetting about the forces of the universe at play. Billions of years ago, a distant star slowly approached our solar system. The forces of these planets affected them, adjusting their orbits and changing the Earth's climate forever. What if this encounter between the stars could lead to a series of profound events leading directly to the birth of life as we know it? Is the influence of the stars the catalyst for the birth of man? And if so, is it even possible? The answers to these questions can change everything we know about life and our place in the world. A recent study suggests that 56 million years ago, a passing star may have impacted the Earth's orbit significantly and changed the climate to make it suitable for life. Can anyone live in this world event? And what are the chances that another star will appear in the future and cause profound changes? For centuries, people have been fascinated by the stars, seeing them as distant, never-changing lights. But what if these distant suns affect our solar system more than we thought? According to a new study, a star passed close to our solar system 56 million years ago, changing the atmospheres of our planets and changing the Earth's climate. This unexpected event may have been the most important event that gave rise to life on Earth, a process that opens up new avenues for planetary exploration and evolutionary biology. The stars are not fixed. They move through space, bringing their crafty powers with them as they approach another star system. While the vast distances between stars make such encounters rare, they do happen, and when they do, they can leave a lasting imprint on the systems they pass through. Researchers at the Planetary Science Institute in Tucson, Arizona, have uncovered evidence that one such stellar transit occurred in the Paleocene epoch, 56 million years ago, significantly altering Earth's environment. To understand the gravity of this event, it's important to recognize that stars are not isolated within the galaxy. They move through space, sometimes passing close to other star systems, including ours. When a star approaches our solar system, its gravitational pull can exert tremendous force on the planets, shifting their orbits and potentially triggering major changes in their environments. Currently, our nearest neighbor is the Alpha Centauri system, which is only 4 light-years away. Although interactions between our Sun and Alpha Centauri at this distance are rare, other stars may have been closer than ever before. According to a study from Arizona, that collision may have occurred during the Paleocene, which caused major changes in Earth's climate and the development of life. The period of global warming known as the Paleocene-Eocene thermal maximum, PTM, was one of the most dramatic climate events in Earth's history. At this time, the Earth's temperature will increase by 8 degrees Celsius, due to the rapid changes in the environment that will allow the development of new species and ecosystems. The cause of this sudden warming has been debated for decades, but a new study suggests that a passing star is the cause. Computer simulations used by researchers show that the influence of a nearby star can change the orbits of the outer planets, Jupiter, Saturn, Uranus, and Neptune. These changes in the outer solar system are caused by changes in the orbits of the inner planets, including Earth. The resulting changes in Earth's orbit may have caused the rapid warming observed during the PTM, creating conditions that allowed for the development of more complex life forms. The idea that a passing star could influence the evolution of life on Earth is both exciting and provocative. The PTM is a time of great biological change, with many new species emerging in response to climate change. The ancestors of modern mammals, as well as prehistoric mammals, began to flourish during this time. A warming climate has created new habitats, increasing food and providing a variety of species. Did the emergence of these new species, including the ancestors of humans, begin with the violent disintegration of a passing star? The researchers involved in this study believe that this is possible. Simulations show that the chance of such a star event occurring in the past 100 million years is 1 in 10,000, a relatively high chance compared to other cosmic events. If this hypothesis is correct, it means that life on Earth and even humans may have been due to an encounter with a stray star. One of the most exciting aspects of this research is the idea that transiting stars may shed light on some of the long-standing mysteries surrounding the orbits of the planets in the solar system. For example, Mercury's current approach to the Sun has long puzzled scientists. Some believe that Mercury is outside the solar system, but was pulled in by Jupiter's force. Likewise, Neptune, the outermost of the giant planets, may have come closest to the Sun before it went outward. In fact, Neptune is so different from its current position that some scientists have suggested it may have originated in an entirely different star system. If Neptune was a rogue planet that wandered through space before being captured by the Sun's gravity, that might explain some of its strange properties. A stellar collision could contribute to this planetary migration and change the solar system as we know it. New simulations by scientists from Arizona show that the stars passing through the planets of the solar system have a significant influence over millions of years. These interactions can explain changes in the variability and slope of the landscape on time scales. The Earth's orbit was not fixed. It changes over time due to the influence of other planets and celestial bodies. But scientists believe that some of the biggest changes in the Earth's orbit are caused by the influence of passing stars. According to the study, the last major change in the Earth's orbit occurred during the Paleocene-Eocene, when global temperatures were increased by a transiting star. This change in orbit is responsible for the rapid warming that occurred during the PETM, which created environmental conditions that allowed the development of new forms of life. One of the most interesting aspects of this study is the possibility that life on Earth could have originated from a collision of stars. Some scientists believe that life was transferred from one star system to another by passing stars, bacteria-laden comets, and asteroids. If life survives the harsh conditions of space, it could travel between star systems in these rare events, with Earth-like planets and planetary blocks. In addition, a star strike can completely replace existing life forms and rapidly evolve new ones. This idea is particularly interesting because mammals, including prehistoric mammals, began to diverge during the PTM. Did the passing star bring about the changes that finally happened to humanity? Earth's climate and global development are very complex systems affected by many factors. While internal processes such as volcanism, plate tectonics and ocean currents play an important role, external forces such as the passing stars are an important part of the equation. New research suggests that we need to expand our understanding of these systems to include the influence of other stars. The simulations used in this study show how a passing star changes how much solar energy reaches Earth and affects the climate. For example, methane emissions from the ocean floor are caused by changes in the Earth's orbit caused by interstellar convection. This release of methane leads to a chain reaction of environmental changes and the basis for the development of new species. Because of the massive impact that a passing star has on the Earth's climate and the evolution of life, it is natural to think that such an event would occur again. According to simulations, another massive interstellar transition is unlikely to occur in the near future. However, this possibility cannot be completely eliminated. Over billions of years, our solar system may have passed through many other star systems, and may do so in the future. Scientists warn that while the chance of an interstellar encounter is small in the short term, the long-term effects of such an event could be significant. A passing star can disrupt the planets, change the Earth's climate, and trigger another evolution. Understanding these planetary collisions is essential if we hope to predict the future of the solar system and life within it. Although much of this research focuses on the influence of transiting stars, it is important to understand the role of the outer planets, especially Jupiter and Saturn, in shaping the solar system. These gas giants are the largest objects in the solar system after the Sun, and their gravitational pull exerts a powerful influence on the smaller planets, including Earth. In particular, Jupiter plays an important role in shaping the orbits of the inner planets. Mercury's massive force has pulled it closer to the Sun, and may one day push Mercury out of the solar system entirely. Jupiter also acts as a protective shield, shielding asteroids and comets that could pose a threat to Earth. Saturn, although not as large as Jupiter, has a strong influence on the solar system. Saturn's famous rings are made of ice and rock, the remains of comets and asteroids that have been broken up by the force of the planet. Saturn's interactions with Jupiter and other gas giants have shaped the orbits of many of the solar system's moons and may have contributed to the planet's decline over time. The discovery of this interstellar collision has renewed interest in the search for other similar events in Earth's history. Astronomers are now using computer simulations to track the paths of nearby stars and determine whether any of them have passed by our solar system in the past. These simulations also help predict when the stars will meet in the future. One of the main challenges in this research is the difficulty in detecting faint and distant stars that have passed close to the solar system millions of years ago. Many of these stars are too faint to observe with modern telescopes, making it difficult to determine their orbits. However, recent advances in astronomical technology, such as the James Webb Space Telescope, should provide more information about the motion of the stars in the galaxy. The idea that life on Earth was affected by a passing star is both humbling and exciting. It shows that the forces that shaped our planet and created humanity are part of a larger story, one that spans billions of years and spans the universe. Although the probability of an interstellar encounter in the near future is low, our solar system may be hit by another passing star. Understanding these world events is essential if we hope to unlock the mysteries of the past and predict the future.